Hi, I'm Sana Friedman.
And I'm Gitali Bhanot. We're both juniors at Oakton High School and we're presenting our project, Managing Hyperlipidemia, Algae as a Lipase Inhibitor.
Hyperlipidemia, or high cholesterol, affects more than 3 million people every year in the U.S. and increases the risk for heart attacks and stroke. Despite the fact that this condition is endemic, available medications to manage it are extremely expensive. As aspiring healthcare providers who are invested in public health issues like this, we want to find a more accessible way to manage hyperlipidemia. We look to East Asia, where there is a significantly lower risk of metabolic disorders compared to the U.S. Some existing literature connects this low risk to a major component of traditional East Asian medicine systems and cuisine, algae. Algae contain a plethora of bioactive compounds like polysaccharides and polyphenols, which have been shown to have lipid-lowering functions. Investigation into this biomedical potential could reveal a natural and more accessible way to manage this epidemic. We hypothesized the following. If the extract of Ascophyllum notusum was added to lipase, a pancreatic enzyme that catalyzes the hydrolysis of fats, then the lipase reaction with whole milk would take the longest. We also generated a null and alternative hypothesis. The fatty acids produced by the lipase reaction with milk reduces the pH of the solution. Thus, the greatest lipase inhibitor can be determined by which solution takes the longest to change from basic to acidic. The bioactive properties of algae vary greatly across different genuses. To come to a conclusion that would best inform further research, we used 3 alga varieties from different genuses for the IV levels: Ascophyllum notusum, a brown seaweed, Rhodaminia palmata, a red seaweed, and Chlorella vulgaris, a type of green microalgae. Powdered forms of the 3 algae were macerated in distilled water for 6 days, then filtered twice, then heated to evaporate the majority of the water. For the experiment, the resulting extract was added to porcine lipase powder in test tubes. After this, 2% sodium carbonate solution was added to make the solution extremely basic, along with bromothymol blue pH indicator and finally whole milk to react with the lipase and create fatty acids. For the control trials, the same amount of distilled water was added instead of an extract. The control served to determine if the addition of an extract had a statistically significant effect on the lipase reaction time. Here are 2 photos from the experiment.
It was said that the more time a trial needed to change from basic to acidic in minutes, the more effective it was at inhibiting the lipase. Thus, the best inhibitor would be the condition with the longest average time elapsed. After collecting data, the graphs revealed that the A. notusum condition did the best, followed by the control. After the control, C. vulgaris did the best by a very slim margin, followed by the R. palmata condition. In order to determine variance amongst the dataset, an ANOVA test was conducted. This revealed that the results are statistically significant since the p-value of 1.32 times 10 to the negative fifth was significantly less than the F statistic of 12.032, resulting in rejection of the null hypothesis. Additionally, the test revealed that the data is statistically different amongst the various conditions because the F critical value was calculated to be 2.867, which is less than the F statistic. Overall, this test revealed that different algae influence lipase reactions in different ways, including in comparison to the control. Further analysis revealed that in addition to the largest average of 10.177 minutes, A. notusum had the largest median value of 10.384 minutes, further asserting its effectivity. As for range, the control seemed to have the largest range of all 4 trials, and this can be largely attributed to the presence of outliers. To determine outliers in the dataset, the interquartile range rule was applied, and it was found that there were 7 outliers in total, 2 in the control, 2 in R. palmata, 2 in A. notusum, and 1 in C. vulgaris. After determining outliers, the elapsed time statistics and ANOVA tests were recalculated without the outliers in each condition. Although all of the averages decreased, the C. vulgaris average and median surpassed that of the control. However, R. palmata remained the least effective. As for recalculated ANOVA, the conclusions still hold true.
Both the original and trimmed datasets produced the conclusion that A. notusum was the most successful, which confirmed the hypothesis. This can be attributed to fluorotannins, a brown algae-specific class of polyphenols that act as a secondary metabolite for the organism. The low success of the R. palmata extract could be due to an inconsistency in the size of the algae particles. While the other 2 were purchased in a fine powder form, we could only find R. palmata in the form of small flakes. Although we tried to use a food processor to turn these flakes into a fine powder, it wasn't 100% successful. Understandably, this may have reduced the effectivity of the maceration process. Although our hypothesis was confirmed regarding the most successful algae type, the behavior of the control defied presuppositions and suggested that there may have been a procedural error. The possible reasoning for this lies in the pH measurement inaccuracies. While equal amounts of sodium carbonate solution with a pH of 11.6 was added to the 4 different sets of trials, the pH of the original solutions were not known. There may have been a significant difference in starting pH between the control trials and the IB trials, which caused the control to have an unnecessarily large pH range to cover along the course of the reaction. Finally, we were limited by our extraction equipment. Without a distiller or rotary evaporator, we relied on standard evaporation techniques to remove the water solvent from the macerated solutions, and thus were not able to create a pure extract.
This experiment opens up many opportunities for further research. Possible routes include exploring the lipase lowering capacities of other brown algae. Additionally, the composition of bioactive compounds in algae has been found to vary based on growth conditions, so this variable should be taken into account. Research should also be done on the different intake types and the optimum dosage of algae-based treatments. Once these treatments are refined, they must be compared to synthetic lipase inhibitors such as orlistat. These are the current medications on the market, and in order for algae-based pharmaceuticals to be a viable alternative, they need to be as effective. Beyond the effects of algae on hyperlipidemia, further research should be conducted on the anti-diabetic, antibiotic, and anti-inflammatory agents found in algae. The opportunities for further research are truly endless and may lead to discoveries that will contribute to the health and prosperity of tomorrow.